Hey gang, we're in step 2 right now. And what I'm going to do is I left this one up here just so I can rewrite the next one. It's going to be the same problem, 2x plus 3 times x cubed plus 3x minus 2. I want to be able to do a comparison. And this is what I'm going to call, this is not the mathematical term, the old school multiplication method. And I call it this because what it does is, now we can move it up here, is it mimics multiplication by big numbers. It mimics, for example, if you have 1, 2, 3, 4 times 45, where you multiply by 5 times 4, then 5 times 3, 5 times 2, 5 times 1, then a 0, 1 times 4, 1 times 3, 1 times 2, 1 times 1. And we'll be able to work there. Have a good night. Alright, so what we'll do is I always take the biggest polynomial, the one with the most terms, and I put that up top. That's an x squared, by the way. Again, absent-minded, and I can't copy worth anything, which is good. That means I have to do all my own work. X squared plus 3x minus 2, and then I'll put the 2x plus 3 underneath it. And I know I'm going to multiply, so I'll put the multiplication way out here so I don't confuse it with an x or anything like this. So if I put it way out here, like I said, we're not going to confuse it at all with any of the variables of x, x, x. We don't want that. If we write everything in standard form, everything is going to be so much easier. So what we're going to do first is we're going to multiply by 3. And it's going to be 3 times a negative 2, which would be a negative 6. 3 times 3x, which would be a positive 9x. 3 times x squared, which would be 3x squared. Now if I jump back here, 3x squared plus 9x minus 6, there's 3x squared plus 9x minus 6. It is the second distribution property. Like I said, we're just organizing it in a different method. Next up, we have our 2x. 2x times a negative 2. So negative 2 times 2 is negative 4. But there's an x there, so it's a negative 4x. What I'm going to do is I'm going to put it underneath the x, because now I have like terms that are in columns. Basically, we're grouping by columns now, so it makes things a little bit easier. So I have 2x times 3x, so 2 times 3 is 6, x times x is x squared, so I get 6x squared. And now I have 2x times x squared. Well, 2 times 1 is 2, because there's a 1 there. X times x squared is x cubed. I don't have a column for that, so I'll put a plus there because it's positive, and I'll just put 2x cubed. So I'll now add the columns of like terms. That's a negative 6. 9 minus 4 is 5x. That's positive. 3x plus 6x, 3x squared plus 3x squared. I know it's going to be an x squared because remember, when we're adding, you can't change the exponents because it'd be like adding 3 pens plus 2 desks. They're not the same thing. But when they're x squares and x squares, what we're really doing is we're trying to figure out how many x squares total do we have. And in this case, we have 9x squares. And then we have 2x cubed, because that's not being added to anything else. So I have 2x cubed plus 9x squares plus 5 minus 6. And I hope I got the same thing as I did before. 2x cubed, 9x squared plus 5x minus 6 minus 6. Now, there's a big difference. Organization. It's just totally different from an organization point of view. Now, if I had to choose, let me zoom out a little bit here. Not in, out. if I had to choose between method number 1 right here and method number 2 right here, I would choose method number 2 because I think vertically. When I do things horizontally, mistakes happen for me. So I know my limitations. I know how I work best. What you have to do is you have to discover which way you work best. So I would mix and match. Or if you really like one method, stick with it and go. And learn that one and master that one way of doing it. The big question would be, are we doing anything illegal mathematically here? And the correct answer to that is no, because I am still distributing by a positive 3, and then I'm distributing by a positive 2. So we're doing a double distribution, just like we did up here. We just organized it totally different. So if you like that method, go for it. If you don't, then don't do it. It's up to you. I am not going to force a method upon you. I don't think that's fair to you. I don't think it's fair to me. And honestly, if I force the wrong method on you, then it's not helping you master the idea of multiplying polynomials, which is what my ultimate goal is. Alright, next video will be method number 3, which is the box method, which is my favorite of all.